Okay, so now let's continue the third part of Monday's lecture. This is where we stopped, so let me go to full screen, turn on the laser pointer. Um, so basically, we said that for the program counter, we were able to read from program counter and write into the program counter in the same cycle by writing in first and reading second. Same thing also happens with, so let me bypass this. The same thing also happens with register, read, and write operations. So let's say that instruction one is going to read and write registers during its cycle. Instruction two is also going to read and write instructions during its own cycle, and then same thing with instruction three. So for instruction one, it reads the contents of the, remember that you always read registers in the second half cycle. So it reads during this half cycle, and then it's going to perform operations, and then it gets ready to write the result of those operations. The writing of the result of those operations actually take place as the clock signal changes from low to high and during the beginning of the first half cycle of the next instruction. Okay, so the next instruction is not going to read the registers until during the first half cycle they're updated. In other words, they're taking the results of the previous operation. They get updated or written into during this half cycle. And then it begins reading the registers after they have been updated. So it reads those registers, and then um, it operates on those registers, and then as it finishes and gets ready to go to the next half cycle, in other words, to write into the registers, then it writes in those registers actually at the beginning of the half cycle of the next instruction during this time here. So that writing always takes place. So during any given cycle, whether it's cycle 3 or cycle 2 or cycle 1, during the first half cycle, you write the result from the previous operation, and then you read the updated results and operate on them during your own cycle. So that's the way you manage to read and write during the same cycle, by writing first and reading second. It's a little bit counterintuitive, but if you think about it, it makes a lot of sense. Basically, what that means is that you get to update something here during this clock cycle, some register here, and then that update is actually written into or takes effect during the next half cycle. And once that effect has taken place, then you read the updated values during the second half cycle. So that's how it's possible to read and write into registers at the same time, by kind of staggering them and creating this little bit of a delay between writes and reads. So keep that in mind. We'll come back to this more as we talk about pipelining a little bit later. So before I finish this lecture, I want to talk a little bit about the convention that we're going to be using for pipelining. And this is a convention that's used in the book. The 5 stages are represented like this. So we have instruction fetch, instruction decode and register access, execution, memory access, and writing back into the registers. So those are the 5 stages of the pipeline. Each stage we assume that takes 200, let's say, nanoseconds, unit of time. So it takes total of 1,000 unit of time or nanoseconds to complete operations of a pipeline. Now the convention is that the units of the pipeline that are affected by a particular instruction are shown in a shaded manner. So like for example, for the add instruction, the program counter or instruction fetch takes effect, so it's shaded. I'll tell you why it's half shaded shortly. The instruction decode and register access is also effective during the add operation. ALU unit executes, therefore it's shaded, but memory is not used during the add operation, therefore it's left white or blank. On the other hand, because this is add and puts the result back into a register, the write back is also affected. Okay. Now another kind of a weird convention that you see here is that sometimes half of a box is shaded and the other half is left blank, like this here, and then the same thing with ID stage, and the same thing with instruction fetch stage. So the convention is that if the first half is shaded, that means that you are writing during that first half. So for write back, even though we have allocated a full stage, you actually write back into the registers during the first half. You see that? And then the second half, if it's shaded, that means that you are reading from the registers. So in this case, you are reading from the registers in order to give them to the ALU for execution, and therefore this second half is shaded. Again, remember that you always write in the first half and you always read in the second half. Now the same thing also happens with instruction fetch, in that you always read in the second half. Now notice that writing back into the PC is not shown in this stage of the pipeline because that's actually during the beginning of the next stage of the pipeline. So that's why this part is blank and the read part is shaded. Another bit of a weird convention is this dashed lines that you see here. This one for write back and also for ID stage. So the reason is that these two are actually the same unit. So the register banks are register banks, register file, and you either read from them or you write into them. But because we are reading and writing at different stages, we are taking the same unit and showing half of it here and the other half of it here. So in fact, if you think of this as a resource that I can kind of put side by side with ID, basically that means that during the first half, this is the same unit. During the first half, I'm going to write into it, that unit, and I'm not going to use this part. And during the second half, I'm going to read from it and not use this part. So that's why these parts are shown as shaded, indicating that they are one and the same. And you can basically put them together to make a solid box showing the resource, which is register file. So with that, I'm going to stop this lecture for Monday. I'll come back to this convention, to this graphical representation of a pipeline later. I hope that you have no more questions about this, and I'll repeat this a little bit more down the road when I reuse it to refresh your mind. So with that, I'm going to stop, and then you make sure and remember to look at the video for Wednesday before I come back and have the lecture on Friday. Thank you and goodbye for now.